off ignition, and we have liftoff of the Titan Centaur carrying the first of two Voyager spacecraft to extend man's senses farther into the...
Voyager 2 has been flying for 47 years. It has visited 4 planets, crossed into interstellar space, and it's still sending data back to Earth today from over 13 billion miles away. Bolted to its side is a golden record, carrying sounds and images meant to explain who we are, just in case something out there ever comes across it. Nobody built that record expecting a reply, but the spacecraft is still moving, the record is still intact, and the question underneath this entire mission has never actually gone away. What happens if someday something finds it?
Voyager 2 launched on August 20th, 1977, riding a Titan IIIe Centaur rocket toward a trajectory that depended on something called the Grand Tour alignment. The outer planets only line up this way once every 175 years, close enough together that a single spacecraft could use each planet's gravity to slingshot toward the next. NASA had one shot to use it. Voyager 2 became the only spacecraft in history to fly past Jupiter, Saturn, Uranus, and Neptune in a single mission, discovering new moons, new rings, and a massive dark storm on Neptune along the way. That part of the mission worked exactly as planned. What happened after Neptune did not.
During the flyby of Uranus in 1986, Voyager 2 detected an electron radiation belt far stronger than anything scientists expected to find there. For almost 40 years, nobody could fully explain it. It was the only close-up data humanity had ever collected on Uranus, and it didn't match any model. Then, in early 2026, researchers proposed an answer. Voyager 2 hadn't caught Uranus in its normal state at all. It had flown through a rare, intense solar wind event that temporarily flooded the planet's radiation belts with extra energy. In other words, Voyager 2 flew through a storm, and scientists spent decades thinking it was the weather. On November 5th, 2018, Voyager 2 crossed into interstellar space, becoming only the second human-made object, after its twin, Voyager 1, to leave the heliosphere, the bubble the sun creates around our solar system. Scientists had modeled a gradual transition at that boundary. Instead, Voyager 2's instruments recorded a sharp, sudden jump in plasma density the moment it crossed over. Temperature readings at the boundary measured between 30,000 and 50,000 Kelvin, far hotter than anyone expected to find in a region of space that should have been one of the coldest environments we've ever measured. The models were not slightly wrong. They were structurally wrong. Voyager 2 runs on radioisotope thermoelectric generators, converting the heat of decaying plutonium into electricity. That power has been declining since launch, and every year NASA engineers have to decide which instrument keeps running and which one gets switched off to save what's left. In October 2024, one of the 5 remaining original instruments was permanently deactivated for exactly that reason. A year earlier, engineers found a small reserved backup power supply, never meant to run instruments at all, and used it to delay another shutdown. That trick only works once. And recently, a routine command accidentally tilted Voyager 2's antenna 2 degrees off from Earth. At a distance of over 20 billion kilometers, 2 degrees was enough to lose contact completely, until the spacecraft's own systems corrected the drift and brought the signal back. Here's where the mission stops being just about data and becomes something stranger to think about. Voyager 2 is carrying a golden record, with greetings in 55 languages, images of Earth, and recordings of human sounds, built under the direction of Carl Sagan. It was never built to reach anyone. It was built in case someone was there to receive it. Realistically, the odds of that happening are almost impossible to calculate. Interstellar space is enormous, and Voyager 2 isn't aimed at any particular star. It will spend hundreds of thousands of years drifting through mostly empty space before it comes anywhere close to another star system. And even then, a close pass is not the same as an encounter. But it's worth asking the question honestly, not as fiction, but as a genuine possibility this mission was designed to leave open. If something with the ability to detect a small metal object did come across it millions of years from now, the record wouldn't just tell them where we were. It would tell them we thought carefully enough about the universe to prepare a message for someone we would never meet, without any evidence that message would ever be read. That's not a claim that it will happen. It's a fact about what we chose to send, just in case it did.
Voyager 2 is still out there right now, still sending data back from beyond the edge of our solar system, still running on power that is quietly running out. At some point, likely within the next few years, the instruments will go silent for good. The golden record will keep moving regardless, carrying a message we built without ever expecting a reply, into a part of space too vast for us to fully picture. We may never know if anyone finds it. That was true the day we launched it, and it's still true now. If you want to see where this same golden record leads, our video on Voyager 1 covers the other half of this story.